A scientific calculator is different than a traditional calculator. Scientific calculators are designed to perform complex operations that are not common to everyday math use. I add, multiply, divide and subtract. In your daily life, when was the last time you needed to calculate the reciprocal of a sum of numbers? You need a scientific calculator to able to perform such operations.
Real audiovisual design requires math. And unless your name is Rain Man, you're probably going to need a scientific calculator to do some of the calculations. There's lots of different calculators out there. There are very simple calculators, and maybe you have one and you like it because it has big buttons. Maybe you've done some business math in the past and you've got a really nice one that you used in school and you favored that one. Or maybe you needed a scientific calculator and you had one of these. We all have our favorites. Let me introduce you to your new best friend. This is the TI-30XS. Why do I make a big deal about this? Because this is a virtual version of this is actually used on our certification exams. And my understanding is it's also allowed on some of the college entrance exams here in the US. Thankfully, they're not expensive. I've seen them from about $14 to $17 US. But you still don't want to get one, do you? Spend the $14 or $17 because you don't want to spend your exam time trying to get or trying to find the functions on an unfamiliar calculator. It's just not a good use of your time. So go ahead and get a TI-30XS and use this as you follow along in our other math videos. Let me show you one thing on here. There's a couple of features that I like. There is a delete key. So you can, if you make a mistake, it's very easy to hit the delete key. There's also an answer key, the little function here, ANS, above the negative sign here. And by the way, to get into any of the functions, just like many other calculators, you'll use a second key to get into these other functions. But let me turn this on. And there's one function that kind of gave me some trouble. When you do some of the loudspeaker spacing calculations, you're using the square root of 2. And we're going to do a square root function here, which is right above the square key. So I'm going to hit second, square root, 2, and then enter. And it says the square root of 2. Well, that's a little frustrating. There's a couple of different ways to fix this. There's a scroll key here that you can use. And then, yeah, square root of 2, 1.41, you would expect that. The other thing you can do, and let me clear all this out, go into mode, and you can see here all the different settings. What you want to do is scroll down to classic and set it for classic mode. So I'm going to scroll down. You can see the classic is flashing. Hit enter, clear all that out. And now when I do something like the square root of 2, I'm getting 1.41 like I would expect. The other nice thing about the TI-30XS is it allows you to fill or put in the entire equation and then just hit the enter key. One of the examples that we did earlier, we did 7 squared plus, and I opened up a parenthesis, 7 plus 7. Let's see, it was times 7 minus 7, close the parenthesis, divided by 7. So we broke it down step by step earlier. Now I've just entered the whole thing, including the parentheses, and it's going to follow PEMDAS. It's going to follow the math order of operations. I hit enter, and we calculated 56 earlier. There it is. I need to know where to put the parentheses and put them in order, and it'll do the rest of the work for me.
Take the time to familiarize yourself with locations of these function buttons on your calculator: log, anti-log, reciprocal, exponent, square root, AV math course conventions. The following list contains the math symbols and formatting within this course. A period is used to separate whole numbers from decimal values. 1.47. A comma is used to separate groups of 3 digits in large values. 1,000,000 measurements are given in US customary, followed by metric in parenthesis. 5 feet, 1.5 meters. Exponents or powers are indicated by a smaller, superscript number. 52 plus indicates when items are to be added, indicates when items are to be subtracted, indicates when items are to be multiplied, indicates when items are to be divided. Square root indicates square root operation. When using formulas, you cannot interchange US customary units, feet or inches with metric units, meters or millimeters. Select one system and use it throughout the calculations. Avoid mixing different units of measure when performing calculations. as this will give you the wrong answer every time. For example, if a screen's dimensions are measured in millimeters, you must continue to use only metric units in the formula. When the calculation is complete, you can convert to the desired unit. Note: caution, units of measure. All math problems in this course have been processed initially using US customary units. Answers in metric units reflect the correct answer when the equation is worked through in metric units. For this reason, the final answers given in US customary and the final answers given in metric are not direct conversions of one another. Using the proper order of operations given a math formula, apply the proper order of operations. Most AV math formulas use only the four common operators: add, subtract, multiply, and divide. However, some formulas require a solid foundation in the order of operations. The order of operations helps you correctly solve formulas by prioritizing which part of the formula to solve first. It is a way to rank the order in which you work your way through a formula. Take a moment to review and test your knowledge of applying the order of operations. This is the order of operations: any numbers within a pair of parentheses or brackets, any exponents, indices, or orders, any multiplication or division, any addition or subtraction. If there are multiple operations with the same priority, then proceed from left to right. Parenthesis, exponents, multiplication, division, addition, subtraction. The order of operations can be remembered by using one of these acronym: PEMDAS, BEMDAS, BIDMAS, or BODMAS. Quick tip: priority of operations. Remember, if the priority of operations is the same, begin solving from left to right. Watch the video, Order of Operations, PEMDAS.
You may have seen an equation like this on social media. Can you solve this? Well, thankfully, there's help for this. It's called our order of operations. One of the ways to remember this, and it's called PEMDAS, and there's a number of mnemonics to kind of keep this in order for you, one of which is, please excuse my dear Aunt Sally. And it tells us that what we need to do first is everything within the parentheses. So we're going to complete everything that's within the parentheses before we move on. Next, we're going to do any exponents or logs, like that 7 squared that we saw a moment ago. The square there would be the exponent, or we may have some logarithmic functions in the equation. After that comes multiplication and division. And multiplication and division carry equal weight with one another, and we will just simply do those left to right. Lastly, we're going to do any addition and subtraction. And like multiplication and division, those two carry equal weight with one another, and we will do those left to right. So now I'm going to take my equation and I'm going to follow the order of operations. The reason we do this is so that we have a consistent result every time. So I need to complete what is within the parentheses. And you can see there's multiple operations here. There's a plus, there's multiply, there's subtraction. So addition, multiplication, subtraction. Which one do I do first? I do the multiplication following PEMDAS. So I'm going to do that 7 times 7. That's going to be 49. So within the parentheses here, 7 plus 49 minus 7. And I'm going to put the rest of it out here. We'll just do this step by step. I'm still within the parentheses, and this is just multiplication and subtraction. So I'm going to do these left to right. 7 plus 49 is going to be 56 minus 7, still operating within the parentheses, divided by 7. So still within the parentheses here, 56 minus 7 gives me 49. So 7 squared plus 49 divided by 7. I still have multiple operations. Which one do? I'm going to do the square. So 7 times 7, 7 squared, is going to be 49, plus 49 divided by 7. Still multiple operations, but I have addition and I have division. Which of these do I do first? I do the division before I do the addition. So 49 divided by 7 is going to be 7. So now we're at 49 plus 7. The only thing left is addition, and that is going to equal 56. And that's how we do all of these multiple operations, following our order of operations PEMDAS. The other thing, when you do equations, not in this example, but if you have any rounding, The rule there is to leave any rounding until the absolute final result so that you don't end up with any rounding errors. So there's two things there. Follow PEMDAS and leave any rounding until the very end.
Sample order of operations calculations. Practice problem 1. 2 plus 5. 82 asterisk 9. Step 1. Anything inside brackets is processed first. Inside the brackets, calculate the exponent first. 2 plus 5. 82 asterisk 9. 2 plus 5. 64 asterisk 9. Step 2. Inside the brackets are now two operations that have the same priority, multiply and divide. Because they are the same priority, begin solving them from left to right. 2 plus 5. 64 asterisk 9. 2 plus 0.078125 asterisk 9. 2 plus 0.703125. This step is typically where people might make a mistake. If the formula is at a stage where the operations are of the same priority, continue solving from left to right. If this step is not completed, you will arrive at the wrong answer. Examine the incorrect processing below. 2 plus 5. 64 asterisk 9. 2 plus 5. 576. 2 plus 0.009. In this example of incorrect processing, multiplication was performed first. The incorrect processing of right to left within the parenthesis means that the final answer will be wrong. Step 3. Now the only remaining operation is addition. 2 plus 0.703125 equals 2.703125. Rounded to the nearest tenth, the result is 2.7. Practice problem 2. 62 plus 4. 3 asterisk 8, 8. Step 1. Anything inside brackets is processed first. Inside the brackets, multiply first. 62 plus 4. 24 minus sign 8. Step 2. There are no more operations in brackets. Calculate the exponent next. 36 plus 4. 24 minus sign 8. Step 3. The next operation is divide. Calculate the division. 36 plus 0.16667, Step 4. The only two operations remaining are addition and subtraction. Both addition and subtraction are the same priority. Solve the formula from left to right. Remember to process from left to right. 36.16667, 8 equals 28.16667. Rounded to the nearest tenth, the result is 28.2. Unit conversions. Conversions between U.S. customary and metric. Given units of measure in one system, convert units to the other system. The audiovisual industry exists all around the world. Likewise, most areas of the world use two common systems, metric and U.S. customary. Therefore, you need to be able to convert from one system to another to maintain accuracy. Converting measurements from one system begins with establishing base units of measure. The common base units for metric are meter, m, centimeter, cm, millimeter, mm. The common base units for U.S. customary are foot, feet, inch, in. To perform the conversion from one system to another, use the following table. To use the table, begin in the left-hand column and locate the unit of measure you are going to convert from. Next, follow straight across the row to the middle column for the desired unit of measure, e.g., from feet to meters. Finally, locate the conversion factor, e.g., 0.3048 units of distance measurement table. Convert from 2 multiply by meters, m, feet, 3.28084 centimeters, cm, inches, in 0.3937008 millimeters, mm, inches, in 0.039370008 feet, meters, m, 0.3048 inches in centimeters, cm 2.54 inches in millimeters, mm 25.4. While proper math rules state that any rounding should be delayed until the final step to avoid rounding errors, for the purposes of this course, it is not always necessary to use a multiplier out to the 100 millionth. For example, many times 3.28084 is rounded off to 3.28, while 0.039370008 is rounded off to 0.03937. Quick tip: U.S. customary metric distance conversions. In practice, you only need one ratio to perform conversions between U.S. customary and metric distance measurements. 1 inch equals 25.4 millimeters. Change meters to millimeters or feet to inches, and use the ratio above to convert. Convert the result from inches to feet or millimeters to meters as needed. Sample U.S. customary and metric conversion calculations. Practice problem 1. How many feet are in 25 meters? Step 1. Using the conversion table, locate the convert from column and find meters. Proceed across the row to feet. Identify the conversion factor. Step 2. Perform the calculation. Total feet equals number of meters asterisk 3.28. Total feet equals 25 asterisk 3.28. Total feet equals 82 feet. Practice problem 2. How many millimeters are in 15 inches? Step 1. Using the conversion table, locate the convert from column and find inches. Proceed across the row to millimeters. Identify the conversion factor. Step 2. Perform the calculation. Total millimeters equals number of inches asterisk 25.4. Total millimeters equals 15 asterisk 25.4. Total millimeters equals 381 millimeters. Converting dimensions on scale drawings. Given the scale of a technical drawing, convert any distance to its actual length. Being able to accurately measure using a scale ruler is an important skill when working with scale drawings. Scale drawings are used to communicate the dimensions of a full-size project on a paper or electronic document. The selected scale is usually in the title block in the lower right corner of the drawing, but may be located anywhere on the plans. A set of drawings may include more than one scale, so you must check each drawing page for its scale. Some drawings may even have multiple scales on the same sheet. Occasionally, several details may need to be called out, but they may not be large enough to require their own sheet. Check the identifying information adjacent to the item to confirm its scale. Converting the scale length to actual length is required to determine actual height, length, width and cable run estimates. Two different scale systems can be found on drawings: U.S. customary and metric. Drawings using U.S. customary measurements usually state the scale using a particular fraction of an inch to represent a foot. For example, you might find a scale on a drawing that shows 1/4 inch equaling 1 foot, as shown in the picture below. This means that 1/4 inch length on the drawing is equal to a 1 foot length in reality. The 1/4 inch equals 1 foot scale is the most common in the US and is also referred to as 1/48 size because there are 48 units of 1/4 inch in 12 inches. Most regions outside of the United States use the metric SI system of units. Millimeters are the standard unit used in architectural drawings and construction language for commercial projects. 1/50 and 1/100 are the most common scales. This means that, for a drawing using 1/100, 1 unit of length on a drawing equals 100 units of the same length in reality. 1/20, 1/10, and other larger scales are generally only used for details. 1/200, 1/500, and 1/1000 are only used for very small scale drawings with little detail, such as the whole floor of a large building or a site plan. A metric scale ruler is shown below. The 1/50 scale on the left indicates that for every 1 millimeter measured, There are 50 millimeters of real distance. The adjacent markings show that the ruler is reading 1950 millimeters for the room dimension, which is the same as the dimension printed on the drawing. Note that below these marking is the 1/500 scale. Always note the scale on the drawing. Also, check that the printed physical scale of the drawing is correct. Consider what would happen if you took a drawing that is the correct scale on a piece of US letter-sized paper that is 8.5 inches x 11 inches, 216 mm x 279 mm, and tried to print it on metric A4 paper that is 210 mm x 297 mm, 8.27 inches x 11.7 inches. The printer may rescale the image to fit the different sized paper, which will result in an inaccurate printout. All of your measurements taken from these printed copies would be incorrect. So, not only should you verify the scale of the drawing, but you should verify its accuracy. You should always check that the document was printed out accurately before making measurements and conversions. Make sure all construction drawings are printed out so that 1 unit of the printed document equals 1 unit of the original drawing. This can be done by checking the measurement of a dimensioned object or an object of known size. Drawings can be inaccurate due to any form of copying or processing. While most original plots from a CAD file should be accurate, though human mistakes can and do happen, anything which has been plotted to fit the sheet of paper, rather than to a specific scale, is likely to be misscaled. All copies of drawings created or modified by printing, as distinct from plotting, photocopying, faxing, or turning into a PDF almost certainly are not accurate. Quick tip: metric scale drawings. If the scale of a metric drawing is 1/50, every unit that you measure on the drawing translates into 50 units in the actual room. You could measure with a normal ruler, metric or inches, and multiply the measurement by the scale. If you measured 51 millimeters on a 1/50 drawing using a normal metric ruler, the length of the actual object would be 51 x 50 equals 2550 millimeters. If you then measured the same item using a normal inch ruler, you would get a reading of just over 2 inches, which converts to 2 x 50 equals 100 inches. Allowing for reading accuracy, the two measurements are almost identical. 2500 millimeters equals 100.39 inches. Sample scale drawing dimension conversion calculations. Practice problem 1. The total length of a measurement from a U.S. customary scale drawing of 1/8 inch is 3.5 inches. What is the actual length? Step 1. Convert the scale 1/8 inch into a decimal format. 1/8 inch scale is 1 divided by 8 equals 0.125 inches. Step 2. Determine the measurement on the scale drawing using a ruler. In this example our measurement is 3.5 inches. Step 3. Divide the measurement by the scale decimal value. In other words, how many 0.125 units go into the measured length? 3.5. 0.125 equals 28 feet, 8.53. Practice problem 2. The total length of a measurement from a metric SI scale drawing of 1/50 is 100 millimeters. What is the actual length? Step 1. Multiply 100 millimeter times the scale unit, 50. 100 asterisk 50 equals 5000 millimeters, 5 meters. Aspect ratio is the ratio of image width to image height. It can be expressed as 2. Aspect ratio is the ratio of image width to image height. AV Math Part 1 Introduction. Upon completion of this section, you should be able to calculate aspect ratio and throw, calculate aspect ratio, calculate throw distance, aspect ratio. Why aspect ratio is important. Whether you are showing an image on a projection screen or display, you need a way to describe that image's width as compared to its height. Do this with a ratio of width to height called the aspect ratio. Aspect ratio is the ratio of image width to image height. It can be expressed as two whole numbers separated by a colon, e.g. 16:9, or by the decimal equivalent of the implied division, e.g. 1.77. Common video aspect ratios include the following: 4:3, 1.33 for standard definition SD video, very common in late 20th century; 16:9, 1.78 for high definition HD video. Some computer and video production displays added space below the 16:9 aspect ratio of HD video and made a 16:10, 1.6 aspect ratio. Every image, screen and display has a specific size based on how it will be used. Your ability to determine the size, aspect ratio of any image, screen or display helps you buy the right product, match a projector's image to the correct screen size, or select the correct image size for a given environment. Without a solid foundation in this area, you may make a costly error determining aspect ratio. Given dimensions of an image, determine aspect ratio to create specifications. Some common aspect ratios include 4:3 and 16:9. A 4:3 aspect ratio means that for every 4 units of width, there are 3 units of height. The same applies for the 16:9 aspect ratio. For every 16 units of width, there are 9 units of height. Aspect ratio formula. The formula for finding aspect ratio is, where AR is the aspect ratio, W is the width of the displayed image, H is the height of the displayed image. Note that W and H are measured in inches or millimeters. There is another useful way to describe an aspect ratio. If you take the 4:3 aspect ratio and divide 4 by 3, the result is 1.33. Therefore, you could alternately describe the 4:3 aspect ratio as 1.33:1, meaning that for every 1.33 units in width, there is 1 unit in height. Again, the same applies for the 16:9. When you divide 16 by 9, the result is 1.78. In the case of the 16:9 aspect ratio, you can alternately describe its aspect ratio as 1.78:1, meaning that for every 1.78 units in width, there is 1 unit in height. Let's take a couple of common computer display resolutions and discover their aspect ratios. First, look at 1024 by 768. If you divide 1024 by 768, the result is 1.33, so the 1024 by 768 computer resolution can be described as having an aspect ratio of 1.33:1. You could also take 1024 pixels in width and divide it by 4 to get 256. 4 units of 256 pixels each, and then multiply one of those pixel units, 256, by 3 to get 768 pixels. Not all displayed images are 16:9 or 4:3. For example, a common computer resolution is 1680 by 1050. Dividing 1680 by 1050 gives a result of 1.6. Therefore, the 1680 by 1050 computer resolution has an aspect ratio of 1.6:1 or 16:10. This is a slightly different aspect ratio than the 1.78:1 or 16:9 aspect ratio. Even though the difference between 16:10 and 16:9 seems small, you cannot project a 16:10 image onto a 16:9 screen. Watch the video, recognizing aspect ratios.
Let's talk about aspect ratios. This is where we relate the image width to the image height, and a ratio is always something to something. So I can have a aspect ratio here that is 16 units wide by 9 units high. So we can write that out as 16 to 9. One of the ways to recognize this is to take the width and divide by the height. So I could take 16 divided by 9, and that gives me the 1.7 repeating. A lot of times we just kind of round this off as a 1.78, and I mentioned something to something for a ratio, so we would say this is a 1.78 to 1. So I can express the 16 by 9 as 16 by 9, or I can express it as 1.78 to 1. We can do this with other aspect ratios as well. We can do this with a 16 by 10. So I can take 16 divided by 10, and that gives me 1.6. So I could say it's a 16 by 10, or I could say it's a 1.6 to 1. We could do this with some older, like 4 by 3, or even older 5 by 4 aspect ratios. The 4 by 3, simply 4 divided by 3. Again, 1.3 repeating. Sometimes we see this as 1.33 to 1. The 5 by 4, 5 divided by 4, gives us a 1.25 to 1. We can use the actual aspect ratios, or we can even use the resolution. Let's take something that we would know, a 1920 by 1080. 1920 being the width, 1080 being the height. So let's take 1920 and divide that by 1080. There's our 1.78 to 1. 1.78 to 1, or also what we know is our 16 by 9. We can do this the same thing with 4K resolution. We can do the consumer 4K, what we know is the UHD, which we know as 3840 by 2160. So let's divide the 3840 divided by 2160. Again, a 1.78 to 1, 16.9. Let's take the DCI 4K resolution. That's going to be a little different. We know DCI 4096 by 2160. So 4096 divided by 2160. You can see 1.89 and the rest of that. Sometimes we refer to this as a 1.9 to 1 aspect ratio. So we're just relating the width to the height, and we can use actual dimensions, or we can actually use the resolutions and come up, and this is just one of the ways to recognize our various aspect ratios.
Quick tip. Documenting aspect resolution. Document the resolution of an image by the horizontal and vertical pixel counts and not by the VESA identifiers, 1920 by 1200 instead of WUXGA. The width and height of an image can also be used to determine a screen's diagonal measurement using the Pythagorean theorem. Screen diagonal formula, Pythagorean theorem. The diagonal of a screen can be calculated using the Pythagorean theorem, where A is the height of a screen, B is the width of a screen, C is the diagonal length of a screen. Watch the video. Aspect ratio math.
Well, we can recognize aspect ratios as like 1.78 to 1, 1.33 to 1, and various numbers like that. 1.78 is actually a rounded number. 1.33 is a rounded number. So if we try and use those numbers when we do our actual aspect ratio math calculations, we can have rounding errors. So instead of using 1.78 to 1, 1.3 to 1, those numbers, we're actually going to do proportions and do the cross multiply and divide for our solutions. So when we're doing proportions, we're going to do width is to height as width is to height. And on one side of this, we're going to use our actual aspect ratios. And on the other side of this, we're going to use our actual dimensions. So let's say, for example, I've got a 16:9 that is 61 inches wide. So I say it's a 16:9, 16 by 9 equals, and I said it was 61 inches wide. And what we're trying to solve for is the height. So I'm going to put x there for a variable. And to solve this, we cross multiply and divide. So I'm going to cross multiply here. So 16 times x equals 9 times 61. Let's do the 9 times 61. That gets us 549. So 16 times x, and we're trying to get x by itself. Now, maybe a long time since you've done these kinds of things. How do I get x by itself? Well, I'm going to take the 16 divided by x. I'm going to take 16 and divide by 16. And we would know that 16 divided by 16 is going to equal 1, and then 1 times x would just equal x, or put x by itself. Well, there's an equal sign here in the middle. So whatever I do to one side of the calculation or one side of the equation, I must also do to the other side. So if I've divided by 16 on this side, I must also divide by 16 on this side. So that's going to give me 549 divided by 16. So 549 divided by 16. So that's going to be 34.3125. Remember, the 1 times x is just going to be x. So we can say that the height of this 16.9, it's 61 inches wide, it's going to be about 34.3 inches tall. And we'll do this for all of our aspect ratio calculations. Okay, so we've done some aspect ratio math where we've taken the width and related that to the height, and you can go back and forth. What about the diagonal relationship? We've got displays that are measured in diagonals. Well, let's find out what the diagonal proportion would be on some of our various aspect ratios. And the way we find out the diagonal proportion is actually using the Pythagorean theorem. So if I have a 16 by 9, 16 units wide, 9 units high, we've got a triangle here. And we're going to apply Pythagorean theorem. So a squared plus b squared is going to get us the ratio of the diagonal equaling c squared. So we know that Pythagorean a squared plus b squared equals c squared. And let's fill this in. 16 squared plus 9 squared equals c squared. So we can go 16, here's our square button, and I'll break this out step by step to begin with. That is 256, and then 9 squared, that's going to be 81 equals c squared. So 256 plus 80, whoops, delete key, 81, 337 equals c squared. Well, I need c by itself. How do I get rid of the square? Well, the way to get rid of the square is take the square root. So I'm going to apply the square root to c squared. That's going to give me c by itself. And again, whatever we do to one side of the equation, we must also do to the other side of the equation. So I'm going to take the square root of 337. So I'll clear all this out. To do the square root, this is the square root key here, the little green looking feature. And to get into that, I hit the second key and then the square root function. Opens up the parenthesis for me, 337, and then I can hit the enter key. And this tells me that the relationship, 18.35755975. That's a lot of numbers. Practically speaking, although we don't round off some of the other numbers like the 1.78, 1.33, those kind of throw us off. Practically speaking, for what we're doing, we can get close enough if we just say it's 18.36. So my 16 by 9 is actually a 16 by 9 by 18.36. Those would be the relationships. 16 by 9 by 18.36 in a 16:9 display. Let's do another one. And let's say this time the diagonal dimension of the display is 90 inches. And I want to discover both the width and the height. So we know 18.36 is to 16. My diagonal is to my width. So 18.36 is to 16. And I know the diagonal dimension. That's going to be 90 inches. What I don't know is the width. So we put x there. We know this is going to be cross multiply and divide. And I could break this out step by step. But what I know is I'm going to multiply 16 times 90 and then divide that by 18.36. So I can enter that into the calculator. 16 times 90, and then divide that by 18.36, hit the enter key, and I'm going to discover that the width of the display, 78, I'm going to round this, you can see the rest of it, but basically it's 78.4 inches wide. I'm going to need to know this dimension because that's going to relate to our closest viewer in a BDM or basic decision making application. Let's discover what the height is to this. So again, 18.36 is to the height, and I know it's 90 inches in diagonal, and we're going to discover what the height is. So again, cross multiply and divide, 9 times 90 divided by 18.36, so 9 times 90 divided by 18.36 gives us a height of basically 44.1 inches. The 44.1 inches gives me my image height, and now I can use that when I start doing my furthest viewer calculations in a BDM or basic decision making application. So just based on the diagonal, I can get my width for closest viewer calculations, and I can get my height for farthest viewer calculations. Um, let's do this in a practical example. Well, I've done all the image size calculations and I discovered that, and I'm doing this kind of in reverse, and I've discovered that I need an image that is at least 44 inches high. Okay, so I need an image, and let's say it's still 16:9, 16:9, and those are my ratios, and I need an image that is at least 44 inches high. Let's discover the diagonal, because things like flat panels, they get classed in diagonal dimensions. So this time I want to discover what the diagonal is in relation to the height. So 18.36, the diagonal, is to 9, the height. I don't yet know what the diagonal is, but I know that my height is 44 inches. So again, cross multiply and divide here. 18.36 times 44, and then we're going to divide that by 9. So 18.36 times 44 divided by 9. 89.76. Rounded, that's about a 90-inch diagonal display. So I can discover whether I can use a flat panel, I need a 90-inch diagonal, and now I can go take a look at specifications and pricing. We've learned the ratio in a 16:9, the diagonal ratio to a 16:9, and it was 18.36. What about some of the other aspect ratios that we deal with? What about, let's say, a 16:10? Let's say, how about an old 4:3? What is the diagonal relationship to these? Well, earlier what we used was the Pythagorean theorem, and we stepped it out step by step. A squared plus B squared equals C squared. And we did the step by step. What was the last thing that we did? We used the square root. So one of the nice things about the TI-30 is we're going to shorten all this up, and we're going to discover what these are. We know that A squared plus B squared equals C squared. And the last thing we did was the square root. So what I can do here with the TI-30 is I'm going to start with the square root. So I'm going to open up the square root. You see the parentheses open there. And let's do the 16:10 here. 16 squared, that's my width, plus 10 squared. And then I'm going to close the parenthesis. We're going to follow PEMDAS here, right? The calculator is going to follow PEMDAS. It's going to do the exponents, the squares, and then it's going to do the addition. All of that within the parenthesis is going to be accomplished, and then it's going to take the square root. So enter, and you can see 18.86796,226. Roughly speaking, we can say this is a 18.87 diagonal relationship on the 16:10. Let's do the same thing with a 4:3. Again, open up the square root, parenthesis is opened up, 4 squared plus 3 squared, close the parenthesis because I need to do all of that before I do the square root, and then I can hit the enter key. Yeah, 5. Some of you would know this as the 3, 4, 5 triangle rather. Let's try a different one. This is a 3840 by 1600 24 by 10 display I saw the other day. It says it has a 37.5-inch diagonal. So this is a little different aspect ratio, but we can do the same thing that we've been doing before. It says it's 3840 by 1600, and it's 24:10. What is the diagonal relationship to this? The same kind of thing. Start with the square root. So we can do 24 squared plus 10 squared. Close that parenthesis. The diagonal relationship here is a 26. Now that I know that, I can go ahead and figure out the width and the height just like we did before.
Sample aspect ratio calculations. Aspect ratio formula. The formula for finding aspect ratio is where AR is the aspect ratio, W is the width of the displayed image, H is the height of the displayed image. Note that W and H are measured in inches or millimeters. Screen diagonal formula, Pythagorean theorem. The diagonal of a screen can be calculated using the Pythagorean theorem, where A is the height of a screen, B is the width of a screen, C is the diagonal length of a screen. Screen diagonal example. The height of the screen is 54 inches, 1,372 millimeters, and the width is 72 inches, 1,829 millimeters. What is the diagonal? Step 1. Determine the diagonal dimension of the screen. Substitute A for screen height, 54 inches, 1,372 millimeters. Substitute B for screen width, 72 inches, 1,829 millimeters. Step 2. Recall the order of operations. First, complete the exponents, then perform the addition. A2 plus B2 equals C2. 542 plus 722 equals C2. 2,916 plus 5,184 equals C2. 8,100 equals C2. Step 3. The length of the diagonal squared is 8,100 inches, 205,740 millimeters. To find the diagonal, C, calculate the square root of 8,100. Square root 8,100 equals square root C2. Square root 8,100 equals C. C equals 90 inches, 2,286 millimeters. Aspect ratio example. You need to project an image that has a 4:3 aspect ratio onto a screen. You measure the screen height and determine that it is 90 inches, 2,286 millimeters, and 120 inches, 3,048 millimeters wide. Can you use this screen for the 4:3 image? Step 1. Determine the aspect ratio of the screen. Substitute W, 120 inches, 3,048 millimeters. Substitute H, 90 inches, 2,286 millimeters. Step 2. Calculate. AR equals 120, 90. AR equals 1.33. Yes, you can use this screen because the aspect ratios match. Throw distance dimensions. Calculating the correct projector position can be complex. The formula for projector position depends on the specific equipment. Manufacturer specifications include instructions for positioning the gear. Projection positioning calculations are usually made in 3 dimensions: x, the horizontal offset of the projector to the screen; y, the vertical offset of the projector to the screen; z, throw distance. If you don't have access to the manufacturer-specific formula, estimating the third variable, throw distance. Throw distance is the distance from a projector to a focusing surface or the screen. The measurement point on the projector varies by manufacturer. Can be useful on its own. Estimating throw distance reveals how far away the projector needs to be from the screen. Your goal is to have an image fill the entire screen surface. Throw distance refers to the distance that a specific combination of projector and lens needs to be from the projection screen to project a specific image size. Throw distance ratios can vary widely depending upon the model, manufacturer and lens type of the projector. Manufacturers tend to have specific formulas that provide the best results for their projector and lens combination. Refer to the owner's manual of your specific projector and lens combination to find the most accurate throw distance and projector position relative to the screen. The projector manual will contain the correct lens information and reference point of measurement, e.g., screen to front of lens. Remember that all lenses are not the same. Also, the distance from the projection screen may vary because screen size and lens zoom ratio will impact projector location. In addition, image processors within each projector can create images of different sizes. Estimating throw distance formula. The formula for estimating throw distance is where d is the distance from the front of the lens to the closest point on the screen. SW is the screen width or width of the projected image. TR is the throw ratio or ratio of throw distance to image width. Refer to the owner's manual of your projector and lens combination to find an accurate formula for your specific projector. Estimating projection throw distance given a lens throw ratio or zoom ratio and image width. Estimate projection throw distance for system specifications. Estimating fixed throw distance recommendation 1. Here are some recommendations when estimating throw distance. When using a fixed lens throw ratio, use a single calculation for a given combination of projector and non-zoom lens. Estimating zoom throw distance recommendation 2. When using a lens that has a zoom feature, use two throw ratio calculations that provide the range from closest distance minimum to farthest distance maximum for a given combination of projector and zoom lens. Watch the video, Estimating Throw Distance.
It is important to learn about a projector's projection throw distance in order to figure out how far away the projector can be located from the image on the screen. A good rule of thumb is to check the manufacturer's information to get a specific projection distance, but in this video, we will show you a general rule that you may be able to apply if you don't have access to that information. The basic equation is to multiply the width by the lens ratio. Here, I have an 80-inch wide by 60-inch high screen. I have two different ratios of 2.0 and 2.5, and let's go ahead and do these equations. For the first example, we're going to work out 80 inches wide times 2.0, which gives us 160 inches. So that means I can place the projector 160 inches away from the screen. For the second example, we're going to work out 80 inches wide times 2.5, which gives us 200 inches. So that means I can place the projector 200 inches away from the screen. It's really that simple. For more information on projection throw distance, check out our AV Math Online course at avixa.org.
Sample projection throw distance calculations. Estimating throw distance formula. The formula for estimating throw distance is where d is the distance from the front of the lens to the closest point on the screen. SW is the screen width or width of the projected image. TR is the throw ratio or ratio of throw distance to image width. Refer to the owner's manual of your projector and lens combination to find an accurate formula for your specific projector. Throw distance example 1. Practice problem 1. A projector has an installed lens with a throw ratio of 2.0:1. The width of the screen in the room is 72 inches, 1,829 millimeters. Step 1. Estimate the distance from the projector lens to the screen. Step 2. Distance equals screen width asterisk throw ratio. Distance equals 72 inches asterisk 2.0. Distance equals 144 inches, 3,658 millimeters. Throw distance example 2. Practice problem 2. A projector has an installed lens with a throw ratio of 2.5:1. The width of the screen in the room is 72 inches, 1,829 millimeters. Step 1. Estimate the distance from the projector lens to the screen. Step 2. Distance equals screen width asterisk throw ratio. Distance equals 72 inches asterisk 2.5. Distance equals 180 inches, 4,572 millimeters. Compare the two calculations. Notice that the screen width stays the same, but the throw ratio determines how far away the projector is from the screen. Throw distance example 3, metric only. Practice problem 3. Here is an example of a metric-only throw distance calculation. A projector has an installed lens with a throw ratio of 2.0:1. The width of the screen in the room is 3,050 millimeters. Step 1. Estimate the distance from the projector lens to the screen. Step 2. Distance equals screen width asterisk throw ratio. Distance equals 3050 asterisk 2.0. Distance equals 6,100 millimeters.